Hey everyone, Mr. Ahmed here. I thought I'd make this video as a supplementary resource, to go over the concepts of horizontal and vertical translations. Again, this video does not replace any of the actual teaching that happened in class, but if you felt like you needed the extra help, that's what this video is here for. I'm also going to be going over the examples that were assigned later in your handout. So if you were looking for help with a particular question, then go ahead and check the video description where you're going to find the timestamps that will allow you to jump to that question. Okay? All right, so let's get started. Well, horizontal and vertical translations, what are they? Well, really, they're just shifts, either up, down, left, or right, of a graph in the coordinate grid. Okay, now there are going to be two different types of translations. You're going to have horizontal translations and you're also going to have vertical translations. Okay, well, horizontal translations occur by shifting the graph either left or right, right? Whereas vertical translations are going to be happening when you shift the graph up or down. Now, maybe you're already putting this together, but horizontal translations are only going to happen if we're shifting or changing rather the x values of points on a graph, right? Y values still stay exactly as they are. The only thing that's changing is the x part of the coordinate, right? For vertical translations, right, the x values themselves are not going to be changing, right? Like if you're going up and down a grid, or sorry, up and down a line, right? The x coordinate's not changing. It's just the y coordinate that's changing, right? Going up and down, okay? Now, horizontal translations can be expressed using replacement notation, okay? Now, replacement notation just means in the equation y equals f of x, what do I replace x by? Right? That's it. That's what this replacement notation means. So for example, if you say y equals f of x becomes y equals f of x minus h, well then you have to understand that the value of x, sorry, not the value of x, the variable x itself has been changed to x minus h. Okay, and that's what we call replacement notation. Okay, so again, that's how x changes in the equation itself. Okay, the transformed function is just you actually taking away that x in f of x and replacing it with x minus h. So that's what your transformed function looks like. Now, as we saw in class, this looks like it's going to be shifting h units to the left, right? Because it's negative. But we also saw in class that it's actually the opposite of what it appears. Okay, so it's actually going to be a shift of h units to the right. Okay, if you need more explanation on that, just ask me again in class. I'll be happy to go over an example with you again. Okay, so this is a horizontal shift to the right. Okay, now mapping notation just means what happens to the coordinate, right? So what happens to the xy coordinate? Well, this is a horizontal translation, so we know that the y coordinate is not going to be changing. The only thing that's changing is the x coordinate. And if we're shifting any point on a graph to the right by h units, then that means you're going to have to take the x value and add on h units. Okay? Now, if you have y equals f of x plus h, well, all of this stuff still applies, right? The replacement notation is you're taking away the x and replacing it with x plus h in your function, right? This is now your transformed function, okay? Now, this is still the opposite of what it appears, right? It appears that, x is maybe moving to the right h units, but as we saw in class, it's actually the opposite. It's moving h units to the left, okay? The mapping notation just means, how do I express the changes, this horizontal shift to the left, for my coordinates? Well, I know I'm moving h units to the left. That means any x value is going to have to decrease by h units. And that's why you go and subtract h. Okay? Now, maybe I'll get kind of Desmos open up here and I can kind of show you guys what that looks like on a graph. So let's say we're working with y equals x squared, okay? Now, that's y equals x squared. Now, if I wanted to say, I don't know, this is shifting 3 units to the right, okay? Well, according to what we saw here, right, a shift to the right is going to be represented by x minus that number, right? The number of digits or units, sorry, that we're shifting to the right. So here if I said, well, I want to shift this guy 3 units to the right, then you have to think, okay, so I actually have to replace the x, okay, replace the x in my equation with x minus the number of units that we shift. That was 3 to the right. So I have to replace x with x minus 3. Okay, so that's what I'm going to do. I'm replacing x with x minus 3. So I'm going to say y equals, I'm going to open a bracket. I'm going to say x minus 3, and then that squared. So notice that now you do have a parabola that is 3 units to the right. Every single point on this initial parabola, y equals x squared, can now be found 3 units to the right of where it used to be. Okay? And again, this is y equals f of x minus 3. Okay, so you'll notice that all that changed here was the x. The x got replaced with x minus 3. The x got replaced with x minus 3. Okay? Now, if I wanted to do a shift to the left, well, I'm going to be adding units, adding units to my x in f of x, right? So I end up with f of x plus h. So that represents a horizontal shift to the left. So let's say I want to go, I don't know, 2 units to the left. Well, then that means that I have to replace x with x plus 2. Okay, so y equals x plus 2, and then squared. So there you go. Now you get this guy here that's shifted to the left 2 units. Okay? Now, horizontal translation is actually, in my opinion, the hard part. Vertical translation is a lot more straightforward. Okay? So for vertical translation, we're moving up or down. So here, our x coordinates are not changing. Okay, the x values in our coordinates, they're not changing. Those guys are staying constant. Because if you move up or down, okay, if you're moving up or down, any coordinate on this line right here, which has equation x equals 5, has x coordinate 5, right? So for example, this point right here has coordinate 5, 1. This coordinate right here has coordinate 5, this point right here has coordinate 5, 2. This point right here has coordinate 5, 3, and so on. So you're noticing that the coordinates of these points on this vertical line, they all have x equals 5. The only thing that's changing as we move up and down is the y value, right? Okay, so the way you represent shifts up or down are by adding or subtracting units or a k value to f of x. Okay, so you can either express that this way or you can express it that way. Okay, now if you want to really clearly see what is happening to my initial function f of x, make sure that you express your equation in this format. Okay, because once you have it in this format, you can literally just read the value plus k, and that will be your shift. And a plus indicates a shift up, and a negative indicates a shift down. Okay, now as before, your replacement notation is just, what you do to y. What do you replace y with? Well, we're going to replace it with y minus k. And then you're going to grab this negative k and you're going to add it on both sides of your equation so that you're isolating for y. Once you've done that, you've got your transformed function. Okay, and as I just said, like 30 seconds ago, plus k means that this is a vertical shift up of k units. Okay, so if we're shifting up k units in regards to the mapping notation, as I've mentioned, x does not change, right? X stays the same. Again, we're moving up and down this vertical line. Okay, what does change is the y value, and if I'm adding k, well then that means that I'm shifting all these y values k units up. Okay, everything that I just said holds true for minus k. Okay, so minus k means we're shifting all of the points up, or sorry, down k units. Okay, and so your mapping notation is going to be y minus k. Again, all those values, all those y points, coordinates, they shifted down k units. Okay, so let's take a look at what that looks like on this graph right here. So I've got y equals x squared. Now, if I say y equals x squared, and let's say I want to shift it up 3 units, I'm going to say x squared plus 3. Okay, so this is y equals x squared plus 3. That means that your parabola shifted up 3 units. Okay, notice that this is not the same thing as this. Y equals x plus 3 squared. Okay, x plus 3 squared is a shift to the left, right? So what, again, y equals x squared. If this is f of x, then this can be represented by f of x plus 3. Okay, and sorry, when I say f of x plus 3, probably should have had my pen out here for that. Let me just get that out real quick. There it is. So when I say f of x plus 3, I mean this. Here we go. This guy right here is f of x plus 3. Okay? And that's not the same thing as this guy right here. This guy right here is f of x plus 3. Okay? That's the difference. Okay? This guy, I'm taking f of x and I'm adding 3 to it. That means it's a vertical shift of 3 units up. Whereas here, I'm taking f of x and I'm actually replacing x with x plus 3. And that means that that's going to be a horizontal shift, okay, of 3 units to the left. Okay, so hopefully that sort of makes sense for, horizontal and vertical translations. Let's take a look at the actual examples. So in this first example right here, sketch the graphs of the following. State the function, the equation replacement, the mapping point, and domain and range using interval notation. Well, that's kind of just what I had on Desmos here. You've got y equals x squared, and then you've got y equals x squared minus 5. Well, we've just seen that when you've got a number outside like this, right, it's away from the x squared, right? So again, consider the x squared as f of x, right? So this is f of x, close brackets, minus 5, right? So that means that you've got the function shifting down 5 units, okay, and that's what you get here, okay. This guy right here is y equals x cubed. Now, y equals x cubed, if I replace x with x plus 5, that means what I'm doing here is I'm going like this. I'm going f of, and I'm replacing x with x plus 5, okay, that's what's happening here. So when I look at that, well, I'm saying, okay, well, that's actually, we remember that horizontal translations are actually the opposite of what they appear. So this is not 5 units to the right, it's 5 units to the left. And that's why I get this graph right here. Okay. Now, for the domain, well, the domain for this guy hasn't changed, right? We're still going up and forever to the right, sorry, up forever and to the right forever, and we're still going up forever and to the left forever, right? So nothing has changed on those ends, right? So domain is still going to be negative infinity excluded to infinity excluded, okay? Your range has changed. Initially, our range was anything above 0, right? Including 0. Well, now it's actually everything above -5, including -5. Okay, so that's why we have this guy right here. Okay. Now your function, well, that's going to be f of x minus 5, right? So this is f of x minus 5. And the mapping notation, well, this is a vertical translation, so my x values stay the same, but I notice that all my y values have decreased by 5, right? So all points on this initial parabola have gone down by 5 units, okay? Now, same thing with this guy right here. So I've got y equals x cubed, and then y equals x plus 5 cubed. We've already seen that this is a horizontal shift of 5 units to the left. Okay, the domain has not changed, right? When I compare it to the initial function, domain has not changed. We're still going again up and to the right forever, and down and to the left forever. Okay, so the domain hasn't changed. Neither has the range, okay, for the same exact reasons. Okay, now your function, I already talked about it, that's how you express it, right? You replace x with x plus 5. And then your mapping notation, well, all coordinates on this line have now moved to the left by 5 units. And that's why you say x minus 5. Okay, so for instance, if you had an x coordinate of 2 here, well, and I don't know, the y coordinate would be 8, right? So if you had an x coordinate of 2, then that coordinate would move to the left 5. And so that coordinate would now be found at -3. Okay? So that's example 1. Moving on to example 2. So in example 2, we've got this absolute value function, right? So y equals the absolute value of x. And they're asking you to graph y plus 2 equals f of x minus 3. Now, as I indicated, as soon as you have something like this, just convert it to this format. Isolate y, and this makes it so much clearer what's happening. I've got a -2, so that means I'm going down 2. And this guy right here, -3, means that it's a horizontal shift of 3 units to the right. Again, a reminder, it's actually the opposite of what it appears to be. It appears like it's going to the left by 3 units. That's not the case. It's actually going to the right 3 units. Okay, so I'm going down 2 units and to the right 3 units. So if I'm going to the right 3 units, my mapping notation is going to be x plus 3. Okay, all my x values are increasing by 3. Okay. And if I'm going to the left, sorry, yeah, just take a look here. Okay, yeah, there we go. And if I'm going, 2 units down, then that means that all my y values are going down 2 units. So that's going to be y minus 2. Okay, and as soon as I've got my mapping notation ready, well, there you go. Now I can just apply that to all of these points. Well, -5 plus 3 is -2. 5 minus 2 is 3. So this point right here, -2, 3, is the image of -5, 5. So here's, where's -5, 5? Here's -5, 5. And the image of that is -2, 3. -2, 3. There's its image. Its image is found 3 units to the right and 2 units down, right? 3 units to the right and 2 units down. Okay, and then you just do the same exact thing for these 2 other points. You put them on your graph, and then you draw your graph, and there's what that looks like. Okay, moving on to question number 3. So for question number 3, given the graph below, graph the transformed function y minus 1 equals f of x plus 2 on the same grid and describe the transformations that have taken place. Again, as soon as you see something in this format, isolate y. It's going to make it so much easier for you to see what's happening with the vertical translation. When I isolate y, I add 1 on both sides. So I end up with f of x plus 2 plus 1. This is a vertical shift of 1 unit up, and this is a horizontal shift of 2 units to the left. Okay, so I'm going to grab each one of these points that I have here on this original graph, and I'm going to shift it 2 to the left and 1 up. Okay, 2 to the left, 1 up, there's that point. I'm going to grab this guy, 2 to the left, 1 up, there's that point. Grab this guy, 2 to the left and 1 up, there's that point, and so on and so forth. Okay, and then now you get the graph of the transformed function. Okay, now in terms of mapping notation, well, a shift of 2 to the left means you're grabbing all of these x values and you're subtracting 2, right? So for example, the coordinates here are 6 and 5. So I subtract 2 from 6 and I get 4. And then I have a vertical translation of 1 unit up. So my point, which was originally 6, 5, goes to the left and now it's 4, 5, but then it also goes up 1. So now it's 4, 6, okay? And there you go. That's why this is the mapping notation. Okay, so that was going over number 3. Now to go over number 4. Describe how the graphs of the following functions relate to the graph of y equals f of x. Well, we've already seen that when you've got -3 like that, that means 3 units to the, a horizontal shift of 3 units to the right. Okay, it's the opposite of what we see. This guy right here is going to be a vertical shift of 4 units up. And then this guy right here, again, as I've been saying, just isolate y, express it in this format, and it just makes it so much easier to see what's happening vertically. Well, that means I'm going to have to add 1 on both sides to isolate for y, and I get y equals f of x plus 10 plus 1. That plus 1 means I'm shifting up 1 unit. This means I'm shifting to the left 10 units. Okay? Okay, going over question number 5. So what happens to the graph of the function y equals f of x if the following changes are made? Replace x with x plus 2. Okay, so I'm going to grab this right here, y equals f of x, and I'm going to replace the x with x plus 2. Okay, so that's what it looks like. Oh, okay, well, we've already seen this. When you've got a plus 2 like this right beside your x, that's a horizontal shift. And it's a horizontal shift that's the opposite of what it looks like. This looks like it's a shift of 2 units to the right. Well, no, it's a shift of 2 units to the left. Okay? Now, this guy right here, we're grabbing y and replacing it with y minus 8. Well, if I replace this guy with y minus 8, then I can go ahead and express, that equation in the same way that I've done this one right here, which is to just isolate y. Okay, so I've got y minus 8, and I'm going to isolate y. That means I have to add 8 on both sides. As soon as you get it into this format, now you can really see what's happening vertically. All my y values originally, whatever those were, are now shifting up 8 units. Okay, so this is a vertical translation of 8 units up. Okay? Moving on to number 6. So the point 2, -3 lies on the graph y equals f of x. State the coordinates of the image of this point under the following transformations. All right, well, I've got something like this. Again, as I've been mentioning so far, make sure that you express this in this format. Isolate y. The reason that you want to do that is because it just makes it so much easier to see what's actually happening vertically. Okay? Now, here you've got -8, so that means vertically I'm shifting 8 units down. Okay, so that means if I grab this point right here and I only shift it down, the only value that's changing here is the y value. Okay, it's still going to be on that same vertical line, right? So x value is not going to change. The only change is going to be the y value, and it's going to be going down by 8 units. Well, if I'm going from -3 and I'm going down 8 units, that means I'm going all the way down to -11, okay? So then the image has coordinates to -11, okay? Now for B here, again, isolate y. That should be your first step. Once you do that, it just makes it so much easier to see what's happening. I've got a shift of 5 units up. That means I'm going to say -3 plus 5, which gives me 2, okay? And then I've got a shift of 7 units to the right. Okay, well then that means that 2 is going to shift, or that point rather, is going to shift to the right 7 units. That means my x coordinate is 2 plus 7, which is 9. Okay. And then finally, moving on to this guy right here. Now this guy's expressed in mapping notation. This means that you're taking all your points and you're shifting them 2 to the right and 3 units up. Okay, so a shift of 2 units to the right means that your original point, which had x coordinate 2, is going 2 plus 2. It's going all the way to 4. Okay, and your initial the y value of your initial point, which was -3, is now going up 3. So -3 plus 3 takes you up to 0. So that's why this guy right here is 4, 0. Okay, moving on to question number 7. So the point -1, 8 is on the graph of y equals f of x. Okay, so this is my initial point. State the mapping notation used, the replacements, and the corresponding point on the graph of that. Okay, My first step here, as I've been saying all this time, is just isolate y, makes it so much easier to see what's happening vertically. Okay, so here's what that looks like. Here's what my transformed function looks like. This means a shift of 4 units to the left, and this is a shift of 9 units down. Okay, so if I want to state the mapping notation that's used, that means that all my coordinates are going to be going 4 units to the left. That means all my x values are decreasing by 4, so x minus 4, and all my y values are decreasing by 9 because we're shifting down. So that's y minus 9. So that's why this right here is the mapping notation. Okay? Now, for the replacements, they're really just asking you, okay, well, what did we replace y with in our transformed function? Well, our transformed function, well, we replaced y with y plus 9. Okay? Regarding x, what did we replace x with? Well, we replaced it with x plus 4. That's all that means. Okay? And they were asking for the corresponding point. Okay, so using the mapping notation here, I can actually figure out what happens to my point, right? So, because I've already done kind of the legwork there, right? So minus 1 minus 4, right, is negative 5. And here I've got 8, so 8 minus 9 is negative 1. So the image of this point has coordinates negative 5, negative 1. Okay, moving on to question 8. So the point 6, negative 3 lies on the graph y minus 3 equals f of x plus 2. Again, your first instinct now is just to isolate y. It makes it so much clearer to see what's happening vertically. Okay, what are the coordinates of the corresponding point on y equals f of x? Oh, interesting. Okay, so this one gives it to us backwards. It actually gives us the image, right, of the transformed function. And it's asking, what are the coordinates of the initial function? Well, that just really means that I have to go backwards, right? Because to go from this initial function to my transformed function, I have to shift 2 units to the left and 3 units up, right? So I'm shifting 2 units to the left and 3 units up. But that means I have to do that shift backwards if I want to get back to what the original point was, right? Because what's happening is I start with a point here, I apply this transformation, and I get this image. So if I want to go backwards, I have to do the opposite transformations to get back to this guy right here. Okay, so that means that I'm going to have to take this point and apply the opposite transformation of 2 units to the left. Well, that means I'm going 2 units to the right. That means I'm going from 6 to 8. Okay, so 6 plus 2 is 8. Now, to go from my initial graph to the transformed function, I'm going 3 units up, and that gets me up to negative 3. Well, to go backwards, I'm going to have to go down 3 units to go back to my initial function. Well, if I have to go down 3 units, well, that takes me from negative 3 down to negative 6. Okay? Okay, so moving on to question 9. If f of x equals x squared minus 3, then describe how the translation y minus 2 equals f of x minus 4 will affect the domain and range of the function. Okay, well, we've already seen that what a parabola looks like. We've already seen what f of x equals x squared looks like, right? So in your mind's eye, you should be seeing a parabola facing up where its vertex, its lowest point, is right at the origin, right? And if you're just like, what is Mr. Ahmed talking about? Well, remember at the start of this video, I was graphing this stuff right here, right? Here's what y equals x squared looks like. Okay, well, it's saying describe the translation y minus 2 equals f x minus 4 and how that affects the domain and range of the function. Well, I'm going to isolate y, right? That's my first step. Okay, that gets me this nice transformed function. I see that I'm actually shifting 4 units to the right, and I'm shifting 2 units up. Okay, well, is that really going to change much horizontally, right? sorry, it will change horizontally, right? It's going to change 4 units to the right, right? It's going to shift your graph 4 units to the right. But what I meant to say is that going to really affect your domain, right? Is that going to change anything that's happening horizontally? Well, if you think about it, not really, right? So here's the graph of x squared minus 3, right? And if I'm replacing x with x minus 4, I'm just expecting that this graph will shift to the right by 4 units. So that's what this guy looks like right here. Okay, so x and then minus 3. Okay, so this is a shift of 2 units to the right. So we can actually see that this horizontal shift obviously isn't going to affect our domain, because these parabolas, whether they're 3 units to the right or not, or sorry, 2 units to the right or not, doesn't make a difference, right? They're still going to be going up and to the left forever, and they're still going to be going up and to the right forever. So your domain isn't going to change, okay? So your domain is still going to be from negative infinity to infinity excluded on both ends, okay? However, your range will change, okay? So initially, we had x squared minus 3, except now, in our transformed function, this is shifting up 2 units. Okay, so yeah, this guy right here is going to be shifting up 2 units. That means I'm actually going to be adding 2. Okay, well, if I add 2, here's what that looks like. Well, minus 3 plus 2 is negative 1, so maybe I can just rewrite that as negative 1, and my graph is not going to change, right? So there you go. Now, in terms of the range, things have changed, okay? We're still going up forever, right? So we are still going all the way up to infinity. Not that we ever get there, right? So make sure that you've got the, for interval notation, you're not including infinity. But our minimum point right now is negative 1, okay? So we're going from negative 1 included up to infinity excluded, okay? Moving on to number 10. So this graph right here is translated 2 units to the right and 3 units down to obtain the graph of y equals g of x. What is the equation of g of x? Okay, so this is my initial graph, okay? And this graph itself is already has already undergone a transformation, but that's not what we care about. We're saying this guy is the starting point, okay? And this guy's translated 2 units to the right. Okay. Well, if I'm translating this guy 2 units to the right, that means that I have to replace x. Okay, I have to replace x with x minus 2, right? Because we know that it's the opposite of what it appears, right? So if I want 2 units to the right, I better write x minus 2, okay? And so here's y equals, and 3 units down. Okay, well, 3 units down just means I have to have a minus 3. Okay, and that's exactly what I'm going to do to this function right here. Okay, so I'm in this function right here, I'm replacing x with x minus 2. Okay, and over here, I've got minus 4, but then I'm going to also add a minus 3, and that's what I do in here. Okay, so I've got x minus 2 plus 2. Okay, now I just decided to write x plus 2, and then I just shifted it to the left, or sorry, to the right 2 units by writing another negative 2, but it's the same thing, okay? And then I've got minus 4, which is this guy right here, and then I apply a vertical translation of 3 units down by writing this minus 3. And then I can just simplify that. Well, x plus 2 minus 2, well, those cancel out, so I've just got x squared. Minus 4 and minus 3 add up to negative 7. Okay, so that was question 10. Moving on to question 11. So a function f of x has a domain represented by the following in set notation. Okay, so x such that x is a value between negative 5 and 4 included on either ends of the interval. And once you've established kind of this interval, then you're stating, well, x is an element of the set of real numbers. Okay, so and a range represented by the following. Okay, so in interval notation, right, we've already seen how to write this stuff in interval notation. We're including negative 5, so we're saying minus 5 comma 4. Okay, that's what that guy is right here. And this guy right here is 0, comma 10. Okay, and that's also included. Now they're saying, what's the domain and range of the image after the translations y plus 4 equals f of x minus 6 has been applied? Okay, again, first step, isolate the y. Get that 4 on the other side and make sure that that y is by itself. When I look at this, I can see that I've got a horizontal shift of 6 units to the right and a vertical shift of 4 units down. Okay, so I just look at how that affects my domain. Okay, well my domain is only going to be affected by my horizontal shift of 6 units to the right. That means my minimum value of -5 has actually shifted 6 units to the right, which means that my new minimum value is actually 1, which is this guy right here. Same thing with 4. This is my maximum x value. Well, this guy right here is no longer 4. I've shifted it 6 units to the right, and that means that my maximum, or sorry, the upper end of my interval is going to be 10. 4 plus 6 is 10. I do the same thing vertically. Now, my original range was this, 0, 10, and I've shifted 4 units down. Okay, well, if I've shifted 4 units down, then that means that my minimum value has now gone down to -4. And my maximum value has now gone down to 6. Okay, so that's why this guy right here is -4 to 6. Okay, and that was question number 11. Okay, moving on to question number 12. So as a result of the transformation of the graph y equals x cubed into the graph y minus 4 equals x minus 3 cubed, point 327 becomes 0.6y. What's the value of y? Okay, well, I look at this equation right here and I know that my first step is going to be to isolate the y. So I'm going to say plus 4, I'm going to add 4 on both ends of the equation here, on both sides of the equation, sorry, and I'm going to get y equals x minus 3 cubed plus 4. Okay, now when I look at this, this means it's a horizontal shift of 3 units to the right and a vertical shift of 4 units up. Okay, well, this is my point. If I shift it 3 units to the right, I do get 6. So that's good, it's already done for us. And if I grab 27 and I shift it 4 units up, well then now I'm at 27 plus 4, which is 31. Okay, so that was question number 12. And we're moving on to question number 13. So here are the original coordinates, here are the transformations, and what are the coordinates of the corresponding image. Okay, so my original coordinates are -1, 6, and this is translated 2 to the left and 4 down. That means that all my x coordinates are shifting 2 to the left, which means -1 is becoming, so I go -1 minus 2, so that gets me -3. And they're shifting 4 units down. That means when I go 6 and down, sorry, when I start at 6 vertically and I go down 4 units, I'm going down to 2. Okay? Now this guy right here, replace y with y minus 2. Well, if I replace y in y equals f of x with y minus 2, and then I isolate y, well, that just means f of x plus 2. That means I'm grabbing any of those initial y values, and adding 2 to them. That means they're shifting up 2 units. Okay, so I can therefore expect, because this is a vertical translation and there's only a vertical translation, that nothing is happening horizontally. That means my 3 is not going to change. Okay, so the x-coordinate is not going to change. But I am moving 2 units up. Well, if I'm at -2 and I'm moving 2 units up, well, that's -2 plus 2. That gets me 0. Okay? My original coordinates here are x and y. Okay, so it's looking like I'm going to be writing the mapping notation for this, right? Based on this, well, this is 5 units to the right and 4 units up. Okay, well, 5 units to the right just means that I'm going to grab the coordinate and I'm going to add 5 units to x. That means x plus 5. And then a vertical translation of 4 units up. So I'm grabbing this y value, or sorry, the y value of my coordinate, and I'm adding 4 units to it. So it's going up 4 units. So that's y plus 4. That's why I get this. Okay. And then finally, now this one's actually asking you to go backwards. Okay. So you've got this image, which is -7, -4, after a translation of 6 units to the right and 3 units up were applied. So that means if I want to go backwards, then I just have to write this, but the opposite I have to write the opposite transformations, right? So to go back from this guy to the initial point, I'm no longer translating 6 to the right, I'm actually translating 6 to the left. Okay, well if I'm at -7, what's 6 to the left of that? Well, -7 minus 6 is -13, or -13. Okay, and if I'm at -4, and that's after I've gone up 3 units, where was I originally? Well, if -4 is after I've gone up 3 units, that means I was originally 3 units further down from -4. That means I was originally at -7. Okay, and then you can actually double check to see if what we did is correct by now going in the correct order, right? By going from your original coordinates, applying these transformations right here, and seeing if you get these coordinates. Well, you do. -13 translated 6 to the right means -13 plus 6 gets you -7. And -7 plus 3 gets me to -4. Okay? So that's question number 13. And finally, question number 14. So here we're being asked to determine an equation in the form y minus k equals f of x minus h, given the following graph of f of x. Okay, so I've got this graph right here of f of x. Okay, y equals f of x is right here. Okay, now I need to know how to get from this graph here to that graph right here. This is the transformed function. Well, all I have to do is pick a point and see what happens to that point on my transformed function, right? That way I can figure out what are the horizontal and vertical translations. Well, the easiest point to pick and to work with is going to be the vertex of your parabola, which happily for us starts at the origin right here. Okay, so this graph right here, you should be recognizing this as the graph of the function y equals x squared, right? And so if I grab this point and I compare it to this point right here, I can kind of see what happens horizontally and vertically, right? Because this guy right here is the image of this guy. Well, to go from this guy to this guy, I've got to shift to the right by, 6 units. Okay, well if I'm shifting to the right by 6 units, I'm going to represent that by f of x minus 6, right? Because remember, it's the opposite of what it actually does, okay? And then I'm shifting down 7 units. That means a vertical translation of 7 units down, which I represent with -7 right here. So this is my answer, except it was asking me to express it in this form right here, where I've got y minus k. So all that means is I'm going to grab this -7 right here, I'm going to add 7, I'm going to get it over onto that side, and there's my final answer. Okay? So hopefully that was helpful, guys. If you have any questions, obviously, ask me in class or shoot me an email. More than happy to help. I highly recommend that you do the extra practice questions in that handout, and you also have the answer key to those. So yeah. All right, well, that's all for me today. See you guys soon. Bye-bye.